In this video, we're going to talk about kinetic molecular theory of gases. This is from Wiley, section 10-1. In this lesson, we'll go over the assumptions of kinetic molecular theory, talk about gas laws, and pressure. So, what is a gas? Well, when we think about gases, we think that molecules in the gaseous phase have no definite shape. They take the shape of their container. Gases have a very high or low density compared to solids or liquids. Well, gases have low densities. Okay, they are measured in units of grams per liter rather than grams per milliliter that you see for densities of solids and liquids. Kinetic molecular theory sounds complex, but actually it makes simplifying assumptions that give us an idea of how gas molecules behave. The first assumption is that gas particles are like spheres, and they're in constant motion, and they're going in all different directions. These spheres collide with each other. They collide with the walls of the container. And when they do, energy is conserved. The gas molecules don't stick together, and they don't get extra energy imparted on them. Also, according to kinetic molecular theory, the gas molecules don't interact with each other. They do not attract or repel. They only collide, and when they do, as we said before, those collisions are elastic. Another assumption is that the volume of the gas molecules themselves don't count, because really if you have gas molecules in a container, it's very similar to 2 or 3 people being inside the volume of the Louisiana Superdome. So there are 3 people in this slide, and those people, their volumes are don't have to be considered if we want to calculate the volume of the entire container. This is what works for gas molecules. The volumes are negligible. So gases that behave according to these assumptions are called ideal gases. Most gases behave ideally at room temperature and 1 atmosphere of pressure conditions. So let's talk about what pressure is. That's a topic that we talk about all the time, but we don't think about in depth. So what are some units of pressure? To begin with, if you think about pressure, you might be thinking of pounds per square inch, atmospheres, or pascals. What causes a gas to exert a pressure? A single gas molecule, if it strikes the container wall, that is a force. But multiple gas molecules, if they strike the wall, that's what pressure is. So when we are measuring pressure, we are measuring lots and lots of gas molecules striking the container. If you heat up a container of gas, the molecules move faster. If the molecules move faster, they strike the walls of the container more often. If the container walls don't move, if they're fixed, they strike the wall more often and with more force. That's how we see an increased pressure if we heat up a container. If you heat up a container and the walls are flexible, then the volume will increase. This is a figure from your book showing a balloon that has flexible walls. If we have a low temperature, the balloon has a certain volume. If we heat those gas molecules up, then the container volume increases. The gas laws quantify these relationships. We'll cover those in our next lesson. The kinetic molecular theory of gases treats gas molecules as small spheres. These spheres bounce off each other. They bounce off the walls of their container. If you have any questions about this lesson, this chapter, or any of the problems, be sure to contact Corey or myself. The main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.